So the other part of that, what we're going to cover in lesson 4.9, perpendicular lines. Let's set up the conditions then for when lines are going to be perpendicular. Non-vertical lines are perpendicular if and only if the product of their slopes is -1. So instead of them having the same slope, when you multiply their slopes, you should get -1. Well, vertical lines are perpendicular to what kind of lines do you suppose? Courtney? Horizontal lines. Yeah, so vertical line and a horizontal line will form perpendicular lines. Anything else for those two intersecting lines to form perpendicular lines are going to have their slopes. When you multiply them together, that product better be -1. Well, tell me, what is the product of a number and its reciprocal? 1. That's the definition for reciprocal. A number and its reciprocal when multiplied together give you 1. Give me an example. 1/2 and 2, right? They're reciprocals? Is half of 2 1? Yes. Give me another example. Let's talk about some negatives.
3/4 times -4/3.
Yeah, -3/4. Its reciprocal is -4/3. So if a number is negative, its reciprocal is negative. Because when you multiply them together, they have to give you a +1. And you can't get a positive without multiplying either a positive times a positive or a negative times a negative. So that's the definition for a number and its reciprocal. So therefore, the product of the number and we need -1 though. So how are we going to get -1? So let's think about -3/4 and -4/3. They're reciprocals. -3/4 and -4/3 are reciprocals. Because when you multiply them together, would we get 1? How could we make it so they would end up to be, if we multiplied it, be -1? So both negatives?
No,
Just one of them. So if we made this positive, a number and the opposite of its reciprocal. So instead of its reciprocal, the opposite of its reciprocal would be -1. So I have a little example here for us. 1/4 times 4/1. 1/4 is the number, 4/1 is its reciprocal. When we multiply them, we get 1. If we wanted to multiply 1/4 by something to get -1, what would we have to multiply it by then? -4/1. The opposite of its reciprocal. Because then we would get -4/4, and that would turn out to be -1. Now, did you notice we said nothing about y-intercepts, did we? So, in other words, we don't have to worry about y-intercepts with perpendicular lines. They can both cross, forming perpendicular lines at the y-intercept. In other words, they're going to share a y-intercept if that's where the intersect is on the y-axis. So it doesn't matter if they have the same y-intercept. The only thing that matters is, are their slopes going to multiply to be -1? If they aren't, they're not going to be perpendicular. Okay, so let's check this one out. Number 5, this was on page, it's just home from the homework page again, page 297. So number 5, y equals 2/3 x minus 4. What's its slope? It's the only thing we have to identify today. What's its slope? 2/3. We don't care about the y-intercept today. We have to with parallelism. We do not have to when we're working with lines being perpendicular. How about our next line? We're trying to determine which, we didn't look at the directions. We're trying to determine which equations represent lines that are perpendicular. So what's the slope of the second one? -3/2. Okay, well, let's just do something right now. If we took 2/3 times -3/2. A number times the opposite of its reciprocal. What should we get? Yeah, we better get -1. A positive times a negative is a negative. And remember when we multiply fractions, we can do stuff like this. 2, those become 1s. 3s, those become 1s. And it does become -1, doesn't it? Okay, I want you, let's take a moment and put those in the calculator and let's see, because right now it's kind of looking like we're going to say they're perpendicular. Let's check it out on your graphing calculator. So turn your calculators on. And go to your y = screen. And if there's anything in there, clear it out. So anything in your y = screen, get it out of there. And if your plot is still darkened up there from us using these the other day, cursor up on that plot that is darkened, press the enter key and it will turn it off. We don't want any plots on. So basically this is what our screen should look like to help us be ready to put our equations in. Okay, so those two equations that we think might probably, because we checked out their slopes and their product of their slopes was -1, the two equations that we think are perpendicular to each other are y = 2/3 x minus 4. So here's how we put in 2/3. Parenthesis, 2 divided by, because that's what fraction bar means, and it'll give you a fraction bar, 3, close that parenthesis. You have to close that parenthesis. We're just showing the fraction 2/3 there. Then we do our x. Remember our x is next to the alpha key. And then we need subtract 4. Now we'll go down to the y⁻2 one, and we will put in the other equation that we believe is perpendicular to it. So negative key, don't use the subtraction key. The negative key is the one down to the left of the enter key in parentheses. You have to make sure you use negative to mean negative and subtraction to mean subtraction. And we got a fraction again, so we're going to put parenthesis. 3 divided by 2 x, and it was +2. Okay, so we have our two equations in. Because we want the graphing calculator to show it with, like not kind of like disform it, we want it to show us that there would be right angles if there are. We're going to do what's called a square graph. So we're going to do a zoom. So press your zoom key and 5 where it says z square. You can just press 5 or you can cursor down to 5 and press enter. And it should graph. Okay, well, let's go back though. Okay, let's go back first of all and do a zoom 6. Let's do that first. Let's do a zoom 6 first. Okay, right now, do they look like they form right angles? No, and it's because of do you have a square screen on that graphing calculator? Yes. Is the screen on your graphing calculator? Right here. Does this look like a square? It's a rectangle, isn't it? Okay, so we need to say, okay, well, since it's a rectangle that we're looking at, we want you to square it up for us. So now we're going to do our zoom 5. And now do they look like there are right angles where they are intersecting? Okay, and how could you tell? Like if you actually had a graph, if this was actually graphed on a piece of paper, how could you tell, without having to get out a protractor and measure those angles, how could you tell if they were, you kind of have to judge and not you can be exactly sure, but how could you check to see if they were right angles in that corner of intersection? We got 4 places we could check, here, 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 and here. Todd?
You can make a square in the corner.
If you can make a square in the corner, you could take the corner of your paper and you could lay it in there, and if it lines up along the line, this edge of the paper and that edge of the paper, you'd say, oh, that looks like a right angle. So for some reason, mine kind of looks like it didn't square it out. I don't know why. Yeah, mine's just not cooperating as well. Does yours look like it's making right angles in your graphing calculator? Okay. Okay, let's turn those off. And let's go go back to our notes. Okay, so we have two more equations here that we're going to talk about. I think we've already decided, let's go down here and write, we've decided that y equals 2/3 x minus 4, and y equals -3/2 x plus 2 are perpendicular. Okay? We're going to write the word once, and then we're going to talk about what is the actually mathematical symbol for perpendicular, since it's such a long word. Anybody happen to know what this mathematical symbol is for perpendicular? Yeah, Elena's got it. It's an upside down capital T. Yeah. So if you want to abbreviate it, you want to use a mathematical symbol for perpendicular, you have an upside down capital T. Okay, so that's, we've already decided those two are perpendicular to each other, and we have our proof up there, don't we? Okay, y equals -1. What kind of a line is that? What's its slope? 0. But you know what? Can we find the slope of the other one, x equals 3? What kind of slope does x equals 3 have? No. Undefined, because that's a vertical line. Well, can you multiply undefined by 0 and get -1? No. And so remember, we set up in our notes here, at the top of our notes, we said, what if we have vertical lines and horizontal lines? We can just say they're automatically perpendicular to each other. So what we will do is we will say, oh, y equals -1 is a horizontal line. And x equals 3 is a vertical line. Well, that means they have to be perpendicular to each other, right? So we're going to say y equals -1 and x equals 3 are perpendicular. Okay, I think I might have said yesterday these will challenge you more, and here's the reason that they'll challenge you more. Your brain will still be on parallelism, where the slopes have to be the same, and the y-intercepts have to be identified, and they have to be different. And can vertical lines be parallel to horizontal lines? No. Vertical lines are parallel to other vertical lines. So today, we get to actually not have to show as much proof, because today we only have to worry about the slopes and whether they're vertical or horizontal lines. So we get to cut down on some of our proof, and we don't have to work near as hard. Like, let's look at number 6 here. Look at our first one. Can we identify the slope from it? What is it? -3/7. Look at the second one. Can we identify the slope from it? -7. We don't have to put it in slope-intercept form because we don't need the y-intercept. We get to say, oh, I only need the slope today, so why bother going through all that work? How about the next one? What's the slope? 1/7. And the fourth line, 7/3. Okay, well, -3/7. Do you think there's any possible other slopes that might be the opposite reciprocal of that? Which one? -3/7. What's its opposite? What's its reciprocal, first of all? -7/3. And what's the opposite of -7/3? Positive 7/3. So we're going to say that these two, and I'm not going to make you do the multiplying. I just want you to process through your head. I want you to say to yourself, the reciprocal of -3/7 is -7/3. The opposite of -7/3 is positive 7/3. So I think we can say that -3/7 x minus 4 and y minus 7 equals 7/3 x minus 3 are perpendicular. Okay, do you think there are any other pairs of perpendicular lines here? Okay. Which pair? Yeah, -7, its reciprocal is -1/7, and the opposite of -1/7 is +1/7. So you're starting to see that, first of all, to even consider that they're going to be perpendicular, one of the slopes has to be positive and the other has to be negative, doesn't it? One has to be rising from left to right, and one has to be falling from left to right. And then they also have to be reciprocals of each other. So we're going to say that y take away 4 equals -7 times x plus 2, and y take away 1 equals 1/7 x minus 4 are perpendicular. Okay. I want you to check out one of those pairs. You get to pick out which one you're going to do on the graphing calculator. You don't have to do it now. But out the ones you got in y equals, you check out either the first set or the second set. Okay, so are there any questions about being able to determine from the equations, without graphing them, which lines would be perpendicular? Anything that's still not clear? Okay, then let's go to the back side where we'll practice some of what we did yesterday with parallelism. And now we're going to do it with perpendicular lines. So same kind of thought process. They give us the equation of a line. So we have a line. This one would be rising from left to right because it has a positive slope. In fact, what is the slope of the given line? 1. And then it has to go through that ordered pair, -1, 2. So it's probably, that point might be over here somewhere. So now we need a line perpendicular to that line, given line, that's going to cross through that point, and it's got to be perpendicular. It's got to form right angles with that one. So we are looking for the red line. We're looking for the equation of it. What would its slope be? -1. The reciprocal of 1 is 1, and the opposite of 1 is -1. So we know that its slope has to be -1 then. Well, that's all the information we need. Now remember, yesterday you get to choose which way do you like to do it. You like to do the y equals mx plus b method, find b, and then set up your equation, or you want to use point slope form and get it put into slope intercept form. I'm going to do my favorite, which is the point slope form way. Okay, now if you don't get the same thing I do, I want you to put it into your graphing calculator anyway. I want you to see why yours would be wrong. Okay, I want you to see what would happen. So these we can put into our graphing calculators. So go back to your graphing calculator, y equals, put in the given line, y equals x minus 6. Put in your perpendicular lines equation in slope intercept form in y sub 2. Do a zoom 5 and see if the lines look perpendicular. Okay, so any questions on number 35? Okay, then and I think we got one more to try here. Okay. Given line, negative 10x plus 2y equals 8. What's the slope of that line? No. What form is it in? Can we get the slope from standard form? No, we can't. It's the only form we can't until we do what to it? Put it in slope-intercept form. So what should we do? Are you just going to do it without me? You can. When you're done, see if you agree with me, and then we'll decide what the slope of this line is. Right? Isn't that what we need? Okay, so what's the slope of this line? 5. M equals 5. Okay. Now we need to go up and say, what's the slope of our perpendicular line going to be? Okay, here's where you're going to make your mistake.
-5.
Not -5, not the opposite. -1/5. You have to ask yourself, what is the reciprocal of 5? It's 1/5. What is the opposite of 1/5? It is -1/5. If you don't, that's the most important step in this whole thing today. You have to make sure you identify what the slope should be properly. Then you can go to work picking what's the method of your choice to get the equation in slope-intercept form. So, go ahead and get an equation for this line that is perpendicular to the given line. This one gets a little trickier because it's, and by the way, even though we don't need to worry about the y-intercept, I'm still going to assess you on, can you get the equation in slope-intercept form correctly? So, over here, if you didn't get the correct y-intercept, I would count that wrong. Even though we don't need to use it, we have to make sure we know how to get them into slope-intercept form properly, whether it's rearranging or substituting into something, whatever we're going to do. What do we have to do to both sides here? I have to subtract 3 without my calculator. What's another name for 3 in fifths? How many fifths is 3? 15 fifths. So I really could say, I'm going to rename this as that 3 as 15 fifths. And then I'm going to subtract 15 fifths from both sides. Because you never know when good old LeGrand's going to say no calculator on this quiz. And we got to know what to do. So y is now by itself, -1/5 x. If you have a positive 4/5 and you take 15 fifths away from it, what do you have? Okay, they have the same denominator, folks. We can just combine their numerators. Don't stare at me like this is the, end of the world. 4 take away 15 is -11. And those are fifths. So we might see our answer written like that. Or we might see our answer in an answer bank as, first of all, cleaned up, subtract 11 fifths. Or we might see it in an answer bank, y equals -1/5 x minus 2 1/5. Then y-intercept change to a mixed number. They will do that. And this is a nice decimal one. What's the decimal name for 2 1/5? 2.2, yeah, so it might be negative 1/5 x minus 2.2. So here's our equation of our perpendicular line. That one we're done.